nitrogen out of the smokestacks and save it. We don't have any right now, but there's blast furnace slag that comes from smelting of metals. I mentioned that in class. And then there's silica fume. When they're making silicone metals, there's the same thing coming out of the smokestacks, this fine powder, and they collect that. So these are what we call supplementary cementing materials, those three. They act like Portland cement to help make the concrete stronger, but they don't have enough strength to work on their own. So they actually help with water tightness, resistance to salt on bridges and parking garages, that sort of thing. And then we have admixture chemicals, which we'll go look over where you put your bags. And you notice we carry those in very small amounts, but those jugs we have over there. Some of the admixture chemicals, yeah, we'll walk over there. We have what we call palladium, which is a water reducer. Hello, you made it. We have palladium, which is a water reducer, and you guys can take a picture of the sides of these. You'll see all the toxins about it. When we want to have strong concrete, we actually want as little water as possible in it. And so what we'll do is we'll add a very small amount of that, and we can cut back on many liters of water by about half a kilogram of water. Something we use in Western Canada and Northwestern United States a lot is air entrainment admixture. If you think of the weather we've got right now, where we have rain and it goes onto our concrete and then it freezes, any of the water that's gone down into the concrete explodes and breaks up the concrete. With air entrainment, it helps hold in microscopic bubbles into that concrete. So when the water goes in, it doesn't quite fill those bubbles, but as it freezes and expands, it allows those bubbles to take on that expansion instead of breaking up the concrete, kind of like a sponge. Just think of it in microscopic form. Big air bubbles are no good, that's structurally a problem, but little microscopic ones allow that water to expand when it's frozen and shrink again, and the concrete doesn't break up. So this is used a lot. Then there's, like we only have these ones here, but there are many other chemicals. So what I will do on Brightspace is open up the SDS sheets for these. You guys can look at those as well for your report. And feel free to take pictures of the toxins. Some are hazardous to the environment, all are hazardous to people, but we use a very small amount. And once it reacts with the chemicals in the concrete, it doesn't leach out, it stays. So, the process we use is with these mixtures here. We will add in, I'm going to stick to just the basic ingredients. The chemicals are added in there as well. Does that cover those 5 chemicals you were talking about?
No.
There's more?
I think you say 4.
Oh, 4.
Yeah.
Okay. Yeah, so there's more. We don't have them here. So we'll add the sand, the rock, the Portland cement, and some water in here. We mix it. And then we dump it into a wheelbarrow. So those that have done the testing in the field would know this. We do testing on a flat surface. We test for what we call slump, how liquid the concrete is or how much it'll slump. So actually, might as well show you guys the cones here. So what we do is using a set of procedures, which doesn't matter to you guys. We fill up these cones level with concrete, and then we pull that off and see how much it sinks. And we measure the difference between the height of this metal cone and the height of the concrete when it sinks. We want to have a certain range of distance, usually between 50 and 100 millimeters drop. And that gives us how flexible the concrete is, how easy it's going to be to place in between forms, that sort of thing. Another test we do, because we added air entrainment in that, is we have these air meter buckets. We'll fill concrete into the bucket, we'll put the lid on, we'll fill it with water to get rid of any unnecessary air, and then adding pressure, we force pressurized air in there and it tells us what the air voids are and how much air we have in there. So material used from this cannot be used for anything else because we've added extra water. So anything that goes in there is automatically waste. most times that is wasted as well. And then we make cylinders. You've seen all these cylinders around the top there. What we do with the cylinders is we have, I'll walk back through here again. These plastic molds, we fill these up with concrete, we harden them, and then we test them at 7 days, 28 days, and 56 days, I think, 50 something anyway, and to see how strong the concrete is. So we make these cylinders, and then we put them in a crushing machine, and we crush them, and see how much resistance they have to breaking. We make a minimum of 6 of these for every truckload or every batch of concrete, depending on what the contract wants us to do. We also sometimes make beams to see how much concrete flexes. That's important when you're looking at a second story that might have concrete beams. You want to make sure that it'll flex a little bit with the load of people walking on it, furniture going on it, that kind of thing. Now, the beams we used to make here, way back when, this was the size we were making the cylinders. Needed a lot more concrete. Therefore, after we broke it, it's a lot of waste. We've downsized it. This is what Canada's standard cylinder size is now. So we don't have nearly as much waste. It still gives us the same approximate in measurements. With beams as well, we used to make these huge beams. And we put them in the machine, and then having pressure come down on the top, here and here, and the bottom there, you see how much it flexes. That's a lot of concrete as well. Just this last year, we've switched to this. So we reduced the amount of concrete we use by about half, just for these beams as well. Less waste for us there. So by reducing the amount that we need for these tests, we've reduced the size of our mix. When we make a mix, or we design a mix, we always design it for 1 cubic meter. Well, that's a heck of a lot of concrete. And you consider that we have 3 groups in here on average for every lab. And with third semesters, they actually have 3 labs. Or 3 labs for each set of tests. They do this 6 times in a year. So that's a lot of concrete. So we've reduced the size of these. Therefore, now we don't design for 1 cubic meter. We design for 1/35. So it's a lot less waste. We still need this concrete to do the tests for slump and air, and that's still waste, and of course a little extra in there. So what Darcy and I started doing when we started working here is we bought patio stone molds out of our own personal money. And now what we do with almost all the waste concrete is we make patio stones. And so my yard has been landscaped, his yard's been landscaped, and a few other staff members have been landscaped. You consider that one of these blocks at a landscaping company, especially this wood grade one, costs you about $35 a block. You know, these are not in perfect condition. These are student made, so there's errors. Some of the strength isn't there. But if it fails on us at home, we will throw it out then and get a new one. So that's how we've reduced the waste. Otherwise, we're throwing out bags like that of concrete into the dumpster. So pollution prevention for us, of course, is reducing the amount we make. It helped Sask Polytech because they have to pay by weight for the garbage. So now there's less weight going out in the garbage, less waste, less cost that way. Trying to think what else we do. Something else we do is when we're curing the concrete, we have to cure it in lime water. Lime is caustic. It can burn your skin. We have to do that because if we cure it it has to be cured in a moist condition so it cures enough. And if we use regular water, what happens is regular water will draw out the lime out of the Portland cement, therefore weakening our concrete. So when we have it in a saturated lime water, it neutralizes that exchange, and we don't lose anything. Currently, our disposal method is just to send this down the sewer drain. We have no other disposal method. So we do maintain this tank through all of the labs and only drain this once a year. When we first came here, Darcy and I, there was usually 2 or 3 tanks and they were changed out regularly. That's the best we can do at this point, but that is an environmental concern that we have.
But changing it just once a year, isn't the temperature being affected?
Yep, temperature will affect it, but we have a heater stuck on the side of it, so it actually heats. So that was another thing that changed, is we had a heater. Way back when I was a student, they actually had an entire room that they used for curing. So we didn't use lime, but it was a steam room set at a certain temperature and humidity. Black mold was a problem. We had a lot of students that would go in there to put their samples in there and come out with some lung problems. So this was the least OH&S, or health safety, thing we could do. Environmentally, there's a switch off. So as we've gone through things, it's changed a bit. But, you know, there's lots of room to talk about those things in your plan. So, water.